All right, guys, today we're going to go ahead and talk about the next two types of congruence. We're going to do angle, side, angle, and then we will work on angle, angle, side. So let's talk about some angle, side, angle. Okay, if two angles and their included side of one triangle are congruent to two angles and the included side of another triangle, then those triangles are congruent. And again, it's very similar to when we discuss angle, side, angle. It has to go in that specific order. So we need to make sure that we go with an angle, a side in between, and another angle. So look, angle, side in between, another angle. That's our goal today, to match those up. Okay, so let's go ahead and make a proof. And again, I'm probably going to type as much as I can because really bad handwriting on the computer. The first statement, as always, is what's given to us. So 1. We're given that DH bisects angle BDF. And we're also told that angle 1 is congruent to angle 2. So first big key parts right there. And our reason being is just it's like given information. So we need to make sure we go back and we put that on there. We got to put it on our picture so it makes sense. Well, the first one I can do that's pretty easy is angle 1 is equal to angle 2. Those I just need arc marks for. Not too bad. I can't specifically use that first part yet because I haven't explained something. Bisect. We talked about this in our last video with our review. Bisect, bisect, bisect. Bisect means right. Bisect means to cut in half. So we're going to cut an angle in half. So let's go ahead and get our colors out again. And it's saying that the line DH bisects angle B to D to F. So that big angle is getting cut by angle H, or by line DH. So I've already used the 1 mark, so I need to use 2. So this piece is equal to this piece. And our reasoning, what are we using here? I guess I keep it to the definition of bisect. Okay, so now we have to write this congruence statement. So we need to talk, first I need to get rid of some of this because it's a little bit in the way. Next I need to talk about how we're going to label that. So let's start with going from red to green. So angle HDB is congruent to angle I went red to green, so I need to go H to D to F. Oops, I need a space. And we did that all based on our definition of bisect. So now we've used both pieces of our given, okay? Cool. And we're trying to do angle, side, angle. So I'm missing a side in between those two angles. Well, duh, that's part of our given, so we need our purple color. So number 3, I don't know why this is still red. Stop being red. Thank you. Number 3 says DH is congruent to DH. And why is he congruent? Well, it's because of himself. And what was that word again? Stop being red, please. He was the reflexive. Okay, let's look. I have a side, or I'm sorry, I have one angle, yes, in green. I have a side in purple, and I have another angle in red. We have angle, side, angle. So on number 4, we're going to say triangle. Oh, let's go with the left one first. Let's start with H. H to B to, and I still can't see the top letter, D is congruent to triangle H to B, so I need to go H to F to D. Sorry, now I'm typing and writing in 2 different spots. And his reasoning, it needs to stop being red, is that we used angle, side, angle. Okay. Sorry about that. Number 2, or technically number 10, but number 2 for today's. The 10th proof we've done so far. Ugh, too many proofs. Okay, number 1's always going to be what? Right, our given. Woohoo! So, well, poop. There's not enough here. The heck? That means we have to look on our picture and let's figure it out. It's easier when they just tell it to us. Oh well. Suck it up, right, Buttercup? So the first thing I see is I have an equal angle. Ooh. I don't know why that's not the same shade, but okay. So I can say angle M is congruent to angle P. Bam, given. Woohoo! What else can I say? Well, what else do I have on here? Let's go back and look. I have a line and I have a line. So I can say line, let's go angle to middle. So MN is congruent to PN because I want N to be equal to itself. It's in the middle, I want him to stay in the middle. I have my angles equal, I need my angles equal. M has to be with P, so M has to be in the same spot as P. And again, all that stuff is given to us. Ha, much better. I like the way that looks. Okay, so I need to go with angle, side, angle. So I have an angle, cool. I have a side, cool. I need one more piece of information. I need that last angle. Well, he needs to be right here. And I'm doing it in the color purple for a specific reason. What have we used so far for the color purple? Purple's the given and like the freebie stuff. So for 2, I'm going to say angle, and I can't say angle N because there's lots of stuff going on in N. So I'm going to be strategic and go based on what I already have being equal. M to N to L is congruent to angle P to N to O. And what's our reasoning? Well, they're our bow tie. They're vertical angles. And vertical angles are always congruent. Well, do I have all my information? Yes. So step 3, our congruent statement. Triangle NML is congruent to triangle NPO. And what's our reasoning? Angle, side, angle. All right, angle, angle, side. Remember, we do not write profanities in math class. So no, we will not do angle, side, side. That does not physically work. You don't write profanities in math class. Sorry, nope, we won't do it. We won't talk about it. Sorry. Okay, angle, angle, side means that I have to go exactly in that order. I have angle, I have angle, and the opposite side. Woo, proofs. Step number one, like always, is to write number one dot given. Easy peasy lemon squeezy. Step number one on the statement side is, well, let's see, A, is everything written in the given actually given, or do I have other pieces on there? Bisect is a vocab word, so that's probably not going to be on there, but hey, I have some markings. So I have at least two things technically given to me. So RP bisects angle SRQ. And angle S is congruent to angle Q. One of those pieces came from the actual writing. The other one came from the picture. Okay, now since I've got some given stuff, we're going to go ahead and use that information. So step number two. We have that definition, that vocab word of bisect. We've used it a couple times, so we're going to think, hey, let's go ahead and actually put that into practice since it's not physically drawn yet. So definition of bisect, because I want to use that vocab word. So RP, which is this guy in the middle, bisects SRQ, and he's an angle. So he cuts that guy in half. So because he cuts him in half, I have the legal right to say, I can't use one because one's already used, so I have to use two. This guy is congruent to this guy. So what is that going to look like when I type it? Angle SRP on the left is congruent to angle, well, I went from the already marked angle to the new one. So already marked as Q, to the new one is R, to the end is P. And I'm like, in the middle of that. All right, I need an angle, and a side. So I see I have an angle, I see I have an angle, I need a side. Now the side has to be something that's not in between the two of them. So our two choices are S to P and Q to P, or R to P and R to P. Well, I have no idea about SP and QP. I have no markings, I have nothing that tells me anything. But I can conclude RP because he's my favorite guy of himself. He hasn't changed. So he's my reflexive property. So PR is congruent to PR, or RP is congruent to RP. Same thing. Step number 4, we have all of our stuff. So triangle SRP is congruent to triangle QRP. And what's his reasoning? Well, his reasoning is side, angle, angle, side. Whew. Okay, last one. Where's my, there you go. It's like my mouse disappeared for a moment. Huh, can't do that without a mouse. So step number 1, like always, 1 dot given. 1 dot, well, what's given? Ooh, so we see some funky things we might not have seen in a while. This guy is equally as important as those guys, because guess what? They mean the same thing. It means they're parallel. So we're going to have to recall all of our knowledge of parallel lines with this problem. But again, it's already given to me, so it's drawn in and written, so it's the exact same piece of information. So I only need to write it once. So XQ is parallel. Parallel has 2 lines in the middle. To TR. Other stuff tells me that XR bisects QT. Cool. So I have my 2 pieces of given. One of them's already used because it's told me they're parallel. It helps for now, but I have nothing I can do with that as of right the second. But I see that word bisects, so I know that I can use for step number 2, wherever my writing went, there it is, definition of bisect. Okay, well, let's see what's getting cut in half today. Right now, I have XR bisects QT. That actually gives us lots and lots of information. So that whole line cuts in half the other whole line. So this guy, XM and MR are congruent, and QM and TM are congruent. Get lots of information in this one. Do we really need both? No, because we only really need one side. Does it matter which side we use? No. Hey, guess what? We had a brain fart moment, which is very typical to happen. It tells me XR cuts QT. Doesn't say anything about going backwards. So can I get to draw all of these? Nope. So we got to make sure we're reading really, 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 really carefully, because sometimes we're going to get tripped up too. So this guy cuts this one. So QT is cut in half. I don't know anything about going backwards. Darn, I thought I had extra pieces of stuff. Oh well. So step number 2. Tells me that QM is congruent to TM. I did that on purpose. Okay. Well, I need some angles, and I've got my side. So maybe my angles have something to do with the parallel part. Well, if you recall, way back in the day when we did it with parallel lines, I knew that opposite inside angles were congruent. I'm doing a really terrible job of trying to put that where I want it to. I knew the opposite interior angles were congruent to each other. And if I pretend here for a moment, I'm going to make that picture look like what's here. Parallel line, really bad attempt at a parallel line, really still not straight parallel line. And a really bad attempt at putting on a transversal. So there's my parallel line and a transversal. Ignoring the other part, pretend this XR doesn't even exist. For a moment, just pretend he's gone. That means that, following with my colors, oops, I lied. I want here, or that angle over by Q is congruent to that angle by T. I can't just say angle Q because angle Q is split a bunch of times. So let's go angle MQX is congruent to angle, well, M to Q, so marked to purple, so M to T to R. And that reasoning is alternate interior angles. But wait a minute. What happens if I were to pretend XR was my transversal instead? Wouldn't that still give me the same information? Ignoring Q and M, ignore that line. Don't I still have another transversal and parallel lines? So according to my picture, I should be able to say that this spot is congruent to this spot by that same definition. So step 3 isn't just that, it's also angle, we'll go keep it consistent, MXQ is congruent to angle MRT. Again, still by the same properties. So now I'm going to, ooh, I didn't want to do that. I wanted to do this. Get rid of my pretend lines. Now if I look back at my picture, I have angle, angle, side. Green, purple, red. Angle, angle, side. Green, purple, red. So number 4 is going to say triangle XMQ is congruent to triangle RMT. And his reasoning, angle, angle, side. Fun with your homework, guys.